Hi, and welcome to an overview of the Rigonomicon.com tool shelf. And even though I try to be as universal as I can with anything learning how to rig, in this case, the tool shelf is very, very much a Maya specific thing. Now, one thing that I want to make clear is that even in the school that I taught recently for rigging, they had a strong bias towards having to use Maya, and they actually almost forbade me from using Blender and a couple of, like, I couldn't even use other software that could be useful to them because the idea right now is that Maya is basically the industry standard for movies and video games and TV and so on. So that's unfortunate because there are certain things that other softwares do or are easier to use for certain tasks. And I'm always a big proponent for understanding as much as possible every software you can. However, I can see from their perspective that they want to give value to their students so that they come out of the program with valuable skills that they can use in the workplace. Now, that's something that we just need to accept, that Maya is still very much the core one that's being used by many of these large companies. Now, there is another part, though, to this. Even though that might be true, there's a part that most people don't want to accept, is that Maya is incomplete. And quite often, here's my proof. If you look at Pixar, okay, that's one of the biggest players out there, frankly. They have their own internal software to do animation. I mean, yes, they have Maya, and yes, they use Maya, but they also have primarily one software called Presto, which you can look it up and take a look at all the videos they have on how things work. In fact, some of the tools and plugins, rather, I should say, some of the plugins that I've written use methods that are very similar to the ones from Presto, and I'll go over those later. But you can also look at DreamWorks, and they have their own internal software. And yes, of course, they are using Maya still, but it's not only Maya. Also, the other big thing, and this is a big one, you gotta rip that Band-Aid right off, right? It's like the concept that a software like this one is all you need out of the box is terrible for your career to be thinking like that. Don't go get into software wars as much as possible. Just avoid them if you can, because the truth of the matter is, each one of these, like, I've worked for many video game companies. For over 20 years, I've been in the industry, and every studio I go to has had its own in-house tools. At the very least, it has a legacy pipeline that you have to adapt to, and they exist for a reason. That most it's not just because of a specific need for their game. It's that Maya out of the box has a lot of holes in it, and you need to find solutions to solve those problems and to get around these small issues. And Autodesk hasn't really been focusing on these things. So they keep adding new things. I'm sure we'll have AI that's going to be integrated into Maya before we have a basic fix for some things that have been there for like 20 years. So with that in mind, keep a little library or a little folder somewhere where you have solutions to these problems. It'll help you long term. Okay, so with that in mind, I'm just going to talk real quickly through all of these buttons. And one thing that's important is, I'm going to go through them with the proper chapter select on YouTube. One thing that you can always do is any of these buttons that are here, I made it so that it's for learning. Okay, so that's the difference between the Rigonomicon and Baconstrip. Baconstrip is basically your source of plugins and things that you can add to Maya that are free, that are optimal, that benefit from GPU acceleration and multi-threading. And the Rigonomicon is about learning, and we just use Baconstrip plugins. Okay, so that's a distinction. All you're going to do is, whenever you want to know something, I've gone out of my way to make sure that all of the scripts are written independently in each one of these, these features here. Like, for example, if I want to know about something bigger, like I'm going to edit this one, and I'm going to go to, how do I set up a bacon roll bone? And here's the commands or the script for it. Okay. Now, normally this is not how we do things. We usually have a library where we import functions and so on, or definitions, and we usually reuse certain functions. But in this case, because that wouldn't help you to learn, it's good to be able to right click on any button and see from beginning to end with nothing hidden, nothing on another file or another thing. It's directly there. You can copy paste this yourself if you can't install the bacon strip shelf. Copy paste this onto a notepad, take it with you to work. It's fine. It'll work. As long, and in the cases where I'm using specific bacon strip plugs, like plugins, you'll have a little tag here saying it's making reference to, in this case, see, it's loading the bacon roll plugin that I created. So just keep that in mind. So there's a couple of these in here, like for example, the RMIK Maya, even though that one technically is using bacon shapes, and maybe I'll make another version where it doesn't use the bacon shapes are just like visuals for bones that Maya can't do out of the box. And even though all the functionality is there, they never put things together so you can, things like simple things like I want to be able to see a sphere or even a line or a box or something circles. Like how many people are using actual NURB circles for their rigs in Maya? It's ridiculous. And not only that, but you can't set them to X-ray or, it's like, this is horrible. So out of the box, it doesn't give you a lot of features. So things like a bacon shape, where it's bacon strip, but it's using the GPU to be able to visualize the bones easier and make it easier for you to select stuff and edit things. So those are useful to you. But anyways, I'm generally good about telling you if there's a plugin that's being used that'll make that script break. So so there's a lot of stuff to go over. So I'll go over them one by one. One last thing I just want to note, and I'm going to try to make this one as short as possible. This one note, it's a big one because I could go into a lot of detail here, and I'll try not to. You're going to have to trust me a little bit when I say when Autodesk wants to get rid of something or phase something out, it's usually money related. I could go into details on how I came to that conclusion because I've been with Autodesk since AutoCAD when the menus were solid blue in MS-DOS. So I've known Autodesk for 30 something years now. I've been using their stuff for over 30 years. That's kind of a scary thought, but when they want to get rid of something, they will get rid of it. They'll phase it out, and there's just no. You have to just deal with that, unless you can somehow convince them not to do it, or if there's enough of a pushback, maybe they'll decide to change that. So PyMel is a very important thing. So it used to be installed with Maya out of the box. But now it's gone. That you can't install it with the Maya installer. So that's what the Bacon Strip Tool 0.3 is. It's like I still haven't gotten to the very first version. So if you're one of my students that's been using my tools beforehand, we were all using PyMel. PyMel is wonderful. I love PyMel. It was great, but now that it's not being installed, you have to install it yourself. And now with 2025 being as bad as it is for installation of PyMel, this is deliberate, obviously. They don't like having another group of people controlling something that is so fundamentally used by everybody. And they really want us to switch over to Maya CMDS instead of PyMel. So Maya commands are, how do I put this? I don't feel good as a coder using it because it's still, even though it's Python, it's just a wrapper. And at least the structure is still Python. Under the hood, it's still Mel. Mel is the Maya encapsulated language, and it's very much string-based. Everything is just like evaluation of strings. Even the reference to an object is a string. And it's really ugly. It can get really ugly. So I can't stand using Maya commands, and that's just to show you how much of an effort I've made. I've rewritten every single one of my scripts so it use Maya commands. Why? Because it's obvious that they just want to get rid of PyMel. And they want us to switch over to that. And the quicker we get that Band-Aid off, the faster we're going to get to being functional. Anybody that's downloading my tools, with the exception of the time it's taking me to put it so that it's available for Mac and Linux, you should be able to use my tools on any version of Maya at this point without having to worry about PyMel or anything like that. And that includes render farms and so on. Okay, so with all that in mind, let's go over each one of these points and let's take a look at what these tools are, why they're here, and how they can help us. Okay, so for the first button, where it just says editors and it has the bacon strip logo, all you need to do is right click on it and you'll have all your options. If you single click it, it will open up the node editor. This button is basically designed to make it easier to find the things that we use on a regular basis. There's not much to it. If you want to open the plugin manager, load certain plugins and unload them, you have it available. The namespace, that's for changing the name of your objects and grouping things together. The node editor is here again in case you don't know about that, the button that you can just press, and of course the reference editor, very handy to knowing which files are being referenced in your scene. So that's it for this button. All right, so now I'm going to talk about the cleaning button. So it's got a couple of nifty things. If you right click it, you'll see that it has a delete history. So if you just want to, just collapse your mesh and not have any of the history, it's a quick way to do it. You can reconstruct the hierarchy. Now this is a very useful little tool. So let's say that in this hierarchy, there's scaling and issues. You can just select any single node that's the root node, or basically where you want to duplicate from. And if you right click here and go reconstruct hierarchy, it will generate all the everything the same way with the same names, only it won't have any scaling or any garbage that goes with it. And also get rid of it'll create it without any shapes or anything. So it'll create a very simple skeleton based on that, and then you can manipulate that. And it'll rename the old one to have the _old. So this is handy when you want to change the scale of something and you want to transfer things from one rig to another. For example, this is kind of a handy thing to do if you want to do a cleanup. I'll be adding some more tools so that you can rescale a skeleton, which is a very important thing when you're dealing with game engines in particular. Scaling can really break stuff. So anyways, that's that tool. I'm going to undo. And now I'm going to go back here. There's another tool that's really handy, which is called report scaling selection. So every once in a while, one thing you got to get used to is that if you have any scaling in your hierarchy, it can create a lot of problems. And Maya tries to bypass that. So let's say if I knew that there was a scale issue somewhere, and there's a child that inherits from something that's been scaled non-uniformly, if I unparent that child, it will create a transform node as a parent of it, even though you're just saying unparent it, so it should be the world should be its parent, right? It should just show up here in the list at the base. But no, it will add another transform on top of it because it needs to have the same scale that its parent had, which is not going to be the same that the world has. Anyways, point is, if you have something like this guy here, I'm going to select the root here, and then I'm going to also select hierarchy. And I've actually gone ahead and made one of these bones not exactly 1, 1, 1 or 100% in scale. One of these is going to have something that's off, and it's a small decimal sometimes that can cause trouble. So finding it would take a long time. So if you just go report scaling selection, it's going to indicate that there's been one scaled object that's been determined, and that there was more information in the basically the output. If you look at the if you click on if you have Maya out of the box with just these tools, and you don't have anything fancy like I do for the scripting part, you can have something with a semicolon down here, like it's an icon that's white with a semicolon, and if you click it, it should open up the script editor. And this is where I printed out stuff that was important. So result for Stormtrooper rough skin, lower arm _L scale, there is a 0.01 on the X, basically. That's what it's detected. So this is kind of handy to go, find stuff out. I was also using this for my students to see if they had not been clean about something, and if they'd left something floating around. It was a nice way of quickly selecting and checking to see if everything was good, because there's nothing worse than having a scale in your rig. This is one of the golden rules of the Rigonomicon.com. It's for a reason. It can really mess up just about everything. So for information, just go in here. Also, one last thing is there's a fix old bacon shape. So for most people, that's not going to be something useful, but that's mostly for my students if they have old scenes that are using the bacon shapes plugin. I'll go over that in a minute, what that is. but this will convert the values so that they conform to the new standard that's been set for bacon shape. Okay, so that's it for the clean button. Okay, for the third button, we have something that's not labeled but clearly has the kind of like an XYZ axis to it. This is the local rotation axis toggle button. So the default one from Maya allows you to do stuff like this kind of thing. And if you are doing that on a joint and you have X-ray on, you will be able to see it. If not, if you do it on like a normal transform, there's no way of having it X-ray view and having that shape show up. So let's say I have something like this, and that's great. That's the one from Maya. This is if you're not aware, if you go into I think it's going to be display. Anyways, I forgot where it is, but here it is. Okay, transform display local rotation axis. If you do Control Shift and click that, whatever menu you have will create a button on that shelf, and it will put that thing that you just pressed, and that goes for anything in here. You Control Shift click it, and it will make a little button. So that's by default like the Maya method for doing that. However, there comes it's kind of annoying because it's a toggle. So if I were to do this kind of thing and go select hierarchy, right, and I click the toggle, well, you're going to have to go back to the individual ones that you turned on and make them toggleable or not, and that's kind of annoying. So to toggle them or not. And then if you right-click it, you'll see that I have a couple of things that I've added. These are my own. It forces all of them off or on depending on which one you need. So if I do this, everything is off. If I do this, everything is on, and so on. So it's just there for us to be able to know which axis points in what direction, because that is critical when you're rigging to understand which axis is what. At the very least, following some of the basic rules of rigging, please take a look at the Rigonomicon basics and looking at the golden rules. They're there for a reason, and I explain why they're there. So this is even though it doesn't seem like much of a button, it is very handy. Okay, so the next button looks like a standard Maya locator. You should find that very easily into create locator. There it is. Okay, and that's got the symbol. Normally this is just a button that I add to my shelf, but in recent years I've started to make it. I've added some new features to that because you're going to be using joints and locators for the most part when you're building your rig. However, locators have a big flaw, which is the core node, like the node it's based on, the transform node, is called a transform node, and it's not based on joints. I won't go into too much detail in this shelf talk, but let's just say that there are advantages using joints over transforms, and generally when you're rigging, you always want to be dealing with joints and none of the other things. So here, what I've done is I've created a menu that allows you to create a default Maya, with its really ugly green that you can barely see where it is. And then you can do a locator joint. This is a locator, but under the hood, it's not a transform. Like if you look at the attributes here, you're going to notice that this is not it's not a transform node. And under the hood, it's a joint now, which is if you select this one, you'll notice this is a transform under the hood. Like the locator has no joint orient or anything related to things that we can use for IK and such. So the default Maya uses the transform node as a core. I made it so that the visual is attached to a Maya joint, allowing you to have, and this is all straight out of the box in Maya. There is a method that I'm using that allows me to transfer the visuals, also known as the shape, of a locator onto a joint, and it doesn't look like a joint anymore, but it is entirely a joint. Other than that, there's also the bacon joint, and you can right click it or you can just normal click. I made it so that and you can always tell right away because it's in this case I'm always making it that brightish blue as a default. And one of the nice things about the bacon joint is that you'll notice that it has visual controls, and you can change it so that instead of a locator shape, you can turn it into a box, and you can make that box any dimension you want. It's got built-in tools that allow you to, like, if you really want to, you can turn it into a circle, and you can make it a circle that has no, it's just purely a circle. One of the advantages of using these kind of things isn't just to simplify, changing the radius and the position of these. Like, I can change very easily what the radius of this circle is just by changing the shape size. But you also have features like X-ray mode, which allows it to appear on being drawn on top of a mesh, which makes it easier to select. You don't have to worry about it being outside the mesh to see it. Also, another one that's very important is wire thickness. How many times have you built a rig where you want to change the wire thickness, but unfortunately the options in Maya are to affect all NURBs? Here you go. It's like, I want to make it a thickness of 4. There it is. And that's just this one. It's like, if I were to duplicate it, I can make this one, just 1. And this is not something you can do out of the box with Maya for some reason. These options are not available. So you have lots and lots of features here, all kinds of shapes. Some of them are very handy for when you're rigging. Every shape that you can want is this list has been growing. I even now have a feather shape if I want to create some basic feather like a wing rig. So even like, you can control if it's also solid, because right now we're seeing it as a wireframe, but if we wanted to, we could make it like something like this for a type of thing where it's now clickable on the inside as well. That activates that thing. And also I talked about things like the Presto tools and stuff like that. Well, here's something I got from Presto. Their rigs are practically invisible. So if I turn the Presto mode on, whenever that makes it, when it's not selected, invisible. But if I click in the right area, it will make it visible. And this is very handy because if you have a skeleton that covers the geometry, like the shape of like, let's say, fingers type of thing, and you're not going to see this, it's not going to interfere when you're previewing it. And then when you click around where the finger would be, it will just select the finger, like the little capsule or whatever it is that you put there. So this is a very simple, like, there's a lot of features in these that help us be able to create our rig. And even though it's deceptive and it comes packed with a ton of stuff in here, you can do a lot of things that should work out of the box out of Maya. Also, this is GPU accelerated, so you don't have to worry about that kind of stuff. Your performance ain't going to take a hit from using this. In fact, it may actually improve it, because using splines may not be the best way to go. But if you're stuck and you have nothing else, I guess splines are good. You're also going to notice that this is a bacon node, or it has a bacon shape because it has the little bacon icon on it. So you know that it is a joint with bacon shape attached to it, much like we had the locator. All right, the next one is this one's very quick. It's just it only has one feature, and this is for creating joints. So if we turn that on, it's the joint tool, so it allows you to create joints. One of the benefits of doing this is whenever you create a joint using the default Maya joint creator tool, you're going to notice that everything is zeroed out. So your rotation values are all zeroed out. If you don't know what that means, there's quite a bit of talk about that in all the videos, especially the rigging basics. You might want to take a look at that. However, the only problem with this tool is that the second that you change anything, there's no tool to adjust these things and keep it zeroed out. You'll have to use something else, and we'll talk about that in a second when we get over to the freezing button. But for the most part, just know that the Maya create a joint tool is very handy. One of the things I've done quite often is I create the one joint, and I just duplicate it and place it where I think it's going to be before I start parenting things. And this is kind of handy to do. So I didn't touch this one. I left it as is. I tried not to change anything in Maya that is already functional. I just made it so it's convenient for you to have it in the shelf. So that's that. Okay, the next button that we're going to be exploring is the match tool. The match tool, if you're not too familiar with this, because in Maya out of the box for a number of years, this wasn't there at all, period. But we've been using it in other softwares, and every time we have to make the transition from another software to Maya, we always ask, please, for the for the love of God, give us a tool that is equivalent to this. And a couple of years ago, Autodesk listened and actually put it in there, and now it's over here under modify, and you can match a translation, a rotation, and a scale, and the pivot as well. But for the most part, let's just focus on the normal TRS. In this case, I've set up a little scene here. We have an object, and it has children. So if I move this around, you're going to see that the children follow. They inherit the transform. And I've created a couple of cubes here that we can use that have different orientations and positions. So if I could go like this. You just select the object you want to transform and the one you want to match to. And if you just single click on this button, it will open up the default Maya one. So I can do something like that and go apply. Now, you're going to see that I have basically the same thing here, but it's quicker. But there's something else that we need to take into consideration. Unfortunately, the match tool for Maya, the default one, does not take into consideration your preserve children option. So let's say, okay, I'm going to close this one. I'm just going to keep this open so we can see the preserve children. Now, if I still have the same selection. If I do match, translate, and rotate, boop, it goes into the right place, and it's exactly the same as what we had before. But if I turn on preserve children, and I use the the usual Maya setup, Maya tool, it will not preserve the children. So in this case, because it's been activated and we're using this tool here, it will preserve the children's position and rotation. And this is really important when you're rigging because you want to have tools that do not affect the children, and you can just adjust one. If not, you're going to end up with scenarios where you have to unparent stuff. So this is one of those things that we talked about before about holes being in the software. If you're doing any form of rigging, this is a fundamental thing that you want to be able to control. If not, you're going to have to do workarounds that are pretty ugly. And the second that you start breaking hierarchies in order to preserve things and then reparent things, you might actually break the rig. So a match tool like this is great. All right, so the next button that we're going to be talking about is the freeze button. The freezing an object in Maya means zeroing out values. So in the case of this rig that I've prepared, once you've done your job, any bone that you click on should give you some sort of zero value on rotation at the very least. Okay, I don't want to go into too much, but there are two types of objects that have transforms in Maya. So everything mesh related, even locators, all that stuff, that's all using something called a transform node. Makes sense. I mean, it's a transform node that controls the transform of an object. But joints are a special case. They don't have a transform node. They are a joint, and their transform is controlled through other things. So if you want to zero out traditionally in Maya, if you wanted to zero out, let's say, translation. So let's say I want this object here to have a zero value in translation. In the past, you couldn't do that because it's a joint, but you can zero out the rotation. Here it's currently not zeroed out. I did that on purpose. So we can see, because we're going to be zeroing that out using the tools. But over here, you can see that the rotate is zeroed out, even though it is definitely not a zero rotation because our coordinate is always relative to our parent, right? So for it to be zero, it'd have to be basically aligned the same way as the parent is to be zero, but this is clearly not zero. So that value exists somewhere on the node. And in the case of a joint, you can zero out rotation by going to something called the joint orient. The joint orient will contain the information that we were looking for, which is the difference to the parent. In this case, it's just a z-axis rotation of 36 degrees. Now, the thing about joints is that you can't zero out the translate. So here we have 2.600, which means it's 2.6 units along the x-axis of the parent, and that's its position. That's its local value, and it's always stored locally, right? So in the past, you couldn't really zero that out without adding an extra node that is like some sort of surrogate midpoint object, which would be exactly where this node is, and then you could zero it out. But you're adding stuff to the hierarchy, and that can have some effects. Also, You don't want to do that for IK reasons as well. Like you're adding nodes to an IK. This could be bad. So for the most part, in Maya, traditionally, you can only zero out the rotation values on joints. And when it came to the other one, the transform node for cubes and spheres and anything with polygons and many other objects in Maya, that object would not be, you couldn't zero out the rotation, but you could zero out the position by freezing it. And that's kind of a problem because if you have controllers for your rig, you want to zero out both the position and rotation, and you couldn't in the past without adding extra nodes, right? So that's generally how we've always added, like how we've done it. We've added these extra nodes, and it would zero out the values. But now in Maya, there's a new method that you can use, which is over here. It's called the offset parent matrix. And now the offset parent matrix, think of it like having a hidden node inside the node, or hidden transform inside an object. And it allows you to do exactly what the joint orient did, or the freeze for geometric objects does. But it's for everything. It can do translation, rotation, and even scale. And it can be stored there without affecting the normal TRS, the translation, rotation, and scale of an object. Okay. We have to be careful with this thing because this was added only a few years ago, and not everything has been adapted for it. Again, this is one of those holes in the software. So for rigging, this is very valuable to us. But so fun fact: if you don't use a joint, you can't skin. The only thing that you can put in a skin, like you can actually skin, like to have influence over vertices, so that it follows an object, has to be a joint. And there's a couple of other things too. Maya's IK won't work. It won't allow you to have anything other than joints. So you have to use joints, and there's even a bind pose, like the information of the bind pose is in a joint as well. So you can't use the other transforms. Which where I'm going with this is that the offset parent matrix is this thing that can confuse it even more, and you can have some issues with using the offset parent matrix because things haven't been adapted. Like a lot of tools have not been adapted to be able to take that into consideration, including some of the constraints. Okay, so if that's true, if we have this wonderful thing called the offset parent matrix, but we can't really use it for anything that we skin in particular, it's a good idea. What I do is I zero out basically the skeleton that is for skinning. I zero out using the joint orient, which is what Maya is expecting. So in the case of all these nodes, I would do something like this. I would select all this, select the hierarchy, and then I would use the freeze tool, and we're going to freeze. I know that the instinct is to go to the joint orient because basically you're transferring the rotate value into the joint orient, so why else would this be here? But in fact, you want to avoid that because you can be in a weird state if you do both rotate, joint orient, and the rotate. What Maya thinks the word freeze means this is where the zero value will go, and then it will figure out where to send it so that it can maintain that zero. So if I do zero rotate and apply, first of all, you're going to find that it gives you an error. And the reason why is because this tool does not like the fact that it's already been skinned, which means you might mess up its bind orientation because it's taking the joint orients into consideration. So this tool is one of those tools where you go, well, it'd be nice if it actually worked, but unfortunately it doesn't. So I've gone ahead and just so that you know, I'm using transform matrix mathematics to calculate the joint orient. So it eventually gets turned into a quaternion, which then gets turned into an Euler value. So if you're worried about that kind of stuff, just know that these tools here are all transform matrix operations or mathematics. So no worries. It's going to be, it's going to work no problem. It's not going to give you some junk values. So if I do 0 by joint orient, well, this is still the error from before, but I'll do it again here just to make sure. Okay, and I go right click 0. You'll see that there's no error with that one because I'm going under the hood, and you'll see that now this has been zeroed out. And these are the two skin clusters because there's two meshes, right? And well, you might not know that, but the armor and the under armor are two meshes. The offset parent matrix hasn't been touched, and it's just going into the joint orient values. There it is. That's where it threw those values that were there before. So now everything's clean and it's okay. It didn't break the skinning or anything like that, and that's a good tool to use. Now, if I wanted to freeze, let's say I create, just imagine that this node here is a controller of some kind. That one would be okay because it'd be outside of the skeleton that's being skinned. In this case, it really is skinned, but just for the sake of visualization, to understand, you can also freeze by parent offset matrix here. And what it's going to do is it's really going to freeze it. It's going to set 0 values to translation and rotation. And it's going to store that. It's going to pull it out of the joint orient. So the joint orient, because we don't want to mix the two, okay? So I pull it out of the joint orient, and then all of it gets put into the offset parent matrix, thus allowing us to zero out an object through the offset parent matrix. Okay. It's complicated for this kind of stuff, I can understand. Just know that there's a tool here that's pretty safe. You can go back and forth, no problem. So if I were to go back here and go freeze by joint orient, you're going to see that the offset parent matrix has been set back to its identity, or meaning 0 values, and the joint orient is now the thing that's driving it, which means also we now have the translate again values in there. So in the case of a controller, it's safe to use the offset parametric method. And in the case of a skeleton, meaning the thing that drives or has the influence over the vertices in a skin, then those should be just using joint orient so that it's compatible with all the stuff that's inside of Maya. Because yeah, even your IK can have some issues with that. Hopefully they will be addressing that in future versions of Maya. In the meantime, just keep that in mind. If you really want to zero things out for controllers, go ahead with the offset parent matrix. Any skeleton, stick to joint orient for safety reasons. Hopefully that will change. And that's it for that button. All right, so next up we have the Align tool, which is probably one of the more important buttons in the Rigonomicon shelf. There's a lot of tools here that may not seem like, well, it doesn't seem like a lot, but these are all very super important when you're building your rig, especially when you want to align bones so that they will work well in an IK, especially the Maya IK, ironically. There's no tools in Maya really to do these tasks. So here I'm going to show you, I've added the default Maya joint orient tool here, and I'll open this up, and I've got this character set up so that we can try to align things so that we get better results for both our gimbal and our IK, so it doesn't pop when we activate a pole vector and so on. So if we look here, we're going to see that this tool primarily works around either using objects as reference or using the world orientation. And that's one of the main issues with this tool. The other issue that you're going to find is, let's say if I look here at this bone, at this joint, the z-axis is pointing a little off from where this axis is pointing. If you look at the axis display, you'll see that they're not very well aligned. This is going to cause us some trouble. And if I go over here, I have a rotation value in the X that's not a 0, and so on. So first thing we're going to find is that if we try to, let's say, use the world orientation to realign this joint, let's say that I want, one of the things we could do is make the y-axis point to the back. So X is always the one that points to the children, so that one's fine. That we're going to keep it like that. Secondary axis is going to be the Y. That's the one we're going to try to take control of. And secondary axis world orientation, meaning what we're going to use as a reference, is going to be the world's Z-axis. Now, this isn't always, if you look at the bottom here, you're going to see my little origin, the origin that Maya has, and we're going to use the Z negative to point towards the back. And so I have it set to Z negative. So we're going to try to align our Y-axis to Z negative. And we're going to also tell it to not reorient all the children as well. So the first thing we're going to find is that we're blocked. The reason is non-zero values. Now the thing with non-zero values is If we use Maya's tools for trying to zero things out, it's also going to fail because it's going to tell us that it can't do a zero out or a freeze of a rotation on an object because it's skinned. So we have multiple things working against us. So we'd have to fix that first. So in the attribute editor, what you could do, if you're lucky enough for your joint orient to be 0 and 0 on the first two, then you could take a chance and just copy the rotation value here, put that to 0 and put it in here. Now just note that this doesn't always work, and it has to do with how rotations are added. If you're doing things by component, the way I'm describing here, I've seen many even tech directors of animation not comprehend this. You can't just add components like you do in a position. A rotation has an order dependency. So you can't just copy the values. You'd have to use a different kind of math in order to be able to add rotations. So you need something to calculate this most often. You do that through quaternion. Usually you use a quaternion solution and then convert that value into Euler. You do the arithmetic with quaternion. So anyways, point is, you could take the chance and try to do this with components. It's very risky to do that. And then this tool will start working. And then even if you fix that, so I'm going to use the freeze tool that I have that does this for us, which uses transformation matrices and then quaternions and then Euler. It's actually very clean result. And you're going to notice that in this case, yeah, it did work. That was okay to do that, but it's not always going to be the case. So that's something that you have to keep in mind. So now that we've done this, now we'll be able to fix this. And it says it's still non-zero values. Okay. And that's because of probably the child node. Child node also has rotate values that are non-zero. So at this point, it's like this is 0. We can clearly see it's 0. This is 0 now, but this is not 0. So we'll just do it with this again. We got a nice clean 0 again. Everything got punched in. And now if we try this, now it'll work. But of course the mesh will spin, and that's bad, right? So we're really fighting everything. So we did fix the alignment of this, but now we're going to notice that the z-axis here doesn't align with the z-axis here as well, just like before. Like before I did this operation, if I undo, you're going to see they didn't align correctly either, and the y wasn't pointing correctly. But it still doesn't really, even if I do this, it still doesn't really fix the problem because this, when you're dealing with IK, think of it as a triangle. We call this usually the solution plane, but the triangle kind of describes where the solution plane exists. I'll explain that. So first of all, you got to think of the hand as a point. So that's one point. The elbow is another point, and then up in the shoulder, that's the third point. And those 3 points together create a triangle. And one of the nice things about triangles, if you've ever looked at rendering, triangles are always flat. And no matter how you put them, that's the whole basis of 3D rendering with triangles. No matter what, even your polygons. When you think of polygons, we don't really talk about polygons because you can have 4 points, for example, just one other vertice, and you could create a surface that is non-flat. In the end, you always have to convert everything into a triangle. So that is our fundamental core, and this is important. I'm going over this because this is a fundamental concept that's in all 3D, including rigging, because you have to align things relative to triangles and always have a normal relative to it. So imagine if this was a triangle, the normal on the surface is basically what we're describing where Z should be pointing for it to be perfectly aligned so that when it bends its elbow, the IK has no trouble finding where it should bend. Okay, so this is a lot of talk about this one tool that we have for Maya already. And there are ways around it, but you have to kind of build dummy setups and or copies of the skeleton, put them flat on the ground, and then realign their axis relative to the world to figure it out. And there's always a lot of eyeballing that gets done. So this is not a good solution for doing it. I left it there because sometimes it does come in handy. I mean, if you want to align a spine, you can definitely use the x-axis as a point of reference, and that will be just fine. Now, if we go back into the align tools, you're going to find there's a couple of things related to this that I will jump to because we're talking about it. So some of the important things to do here is like aligning an x-axis to point to the child. We talked about this very briefly a moment ago. So if I look at like let's say these nodes here, you'll know that they're well aligned or not. Okay, I'm just going to go to the channel box. You'll know that they're well aligned when only the x-axis has a value and the y and z are 0. That's in the case of the first phalange or the first finger. It's always going to be some funky numbers because the hand never points directly to any one finger, because if it did, all the other fingers would not be pointing, would not have its parent pointing at it. There's only one of them that could have it, or none of them, right? So in this case, none of these first phalanges will ever have values that are, because remember, it's a position, so it's relative to its parent, which means it's where it is from it. And the next finger should have a value that's something in x, 0, 0. So in this case, it's well aligned. And this one is also well aligned. And that defines what a proper finger joint would be. It's a certain amount of distance on the x-axis away from the parent. That would mean that the x-axis is pointing directly at the child. And to fix those kind of things, I believe the new version, the new tools in Maya have a smart joint orient tool, but in the end, it's basing itself on averages. So we want a little bit more precision. And normally, I write this tool in just about every software I have to use. So all you have to do is, let's say I have something like this. Yeah, something like that, where you have a value like this one. If I want to get this to point in the right direction, so I get it so that this points there, but keep that position, I just select the child node, right? And then I go up into the line, and I go realign x-axis. And now it's going to have the same position, but the parent now is pointing directly at it. And as a result, my value is something 0, 0. And it's realigned the parent to point towards the child. Okay, so this works with any object. Also, another thing to note is that you generally want to also control the z-axis. So in the case of this bone here, it's not, if you look at it, it's not very well aligned with the z-axis of its parent. That's on once you have those two axes, the x and the z, well aligned, that's really good for bending, like even fingers. You want to have that so that all the phalanges, the distal phalanges and the proximal phalanges, all have the same point where they rotate, so you don't get any wonky fingers. You want them to be all on the same axis of rotation. So a z-axis is also important to align. So basically, I did the same thing there, where you have a line, and you can say realign parent, realign to parent. In this case, the child is adjusting to the parent because that's generally what you want to do. So here, the z-axis, you'll notice this didn't take any, like you didn't, the tool, this is something fundamental, and it was just a one click away, right? And it does all the heavy math for you. It finds the current alignment relative to the parent, and then finds a way to match the two together. And hopefully the new tools from Maya will address this, but something tells me it won't. But anyways, so the important thing here is now you have a z-axis that is aligned the same way as the parent. So, and if for whatever reason the x-axis is now misaligned as a result of that, in this case, because it's like a spinning on the x-axis to get the z-axis to point in the right direction, it won't affect the z. So we're okay. I mean, it won't affect the x, so it's fine. This guy also fine. So we're good. So just with those tools alone, we already have a number of things done. Just to finish off, we have two more things related to these kind of bones. So I'm just going to undo here. Get rid of the things. Actually, you know what? I can just reload it. Reload it so that we have the wonky axis. And I created this little locator here just to help us out. And so let's say that you remember the 3 points on the triangle. We want to align the let's say the shoulder so that it matches correctly with this angle, and create a perfect triangle. So it knows, basically, like I said, it's as if, imagine it's a triangle that's being created, and the z-axis is the normal on that triangle. So we want to make this z point along that triangle normal, and then the x-axis, we want to make sure it points to the child node. So I'm going to use this as a point of reference if you want to make it easier to understand. So all I do is select this, and then I select the hand, because that's basically the leaf node of the triangle, and I will go and find the parents. You never want to go the other way, because you can have multiple children, but you can only have one parent. So by selecting the hand, you've basically described to me the triangle. It'll go up the hierarchy to find the other two. And that's actually pretty safe to do. So I'm just selecting this object, and I'm saying, now line this relative to this triangle by using the hand as a point of reference, and put it so that it's on the shoulder. This is going to be the top one. If I press that, it will be showing me how it should be aligned to match that triangle. In this case, it's actually aligned correctly. So all is good. Now, if I wanted to, I could affect this directly and get it to be aligned properly. And we're going to do that with the elbow. That's the middle one. So instead of using this object, I'm going to use the object itself and fix it. And the first thing you're probably going to think of is, well, if I do that, any form of modification here is going to affect the skin. I wasn't going to go over this yet, but what I'm going to do is I'm going to select the two meshes and go to the skin button. This is for the later part of the video. And I'm just going to deactivate it. I won't go into details yet. So basically, all you need to know right now is that if I do things, the skin will not be affected. Okay, now the other thing is, most of these tools that you have in Maya don't take into consideration, for some reason, the preserve children feature that Maya has. So I made sure that these tools, when you do adjustments and things like that, if you have the preserve children, it'll detect that you did this and keep the child nodes in their place. So if I select this now instead of the locator, and I select the hand because that's the last the leaf node in the triangle, that's child, so I can find the parents, as I explained. Now, if I want to align that, I can go into align, and this time it's the middle one, right? It's the elbow. So now it's realigned the z-axis and the x-axis and everything. So now what we need to do is reactivate the skin so we can see what's going on. I'm going to reactivate the skin. Now if I select this and I rotate on its z-axis, preserve children still on, you'll notice that everything is hunky-dory. Everything's nicely aligned. And if I were to create an IK here, it wouldn't pop as long as I've zeroed out my values, which I believe the tool that I wrote automatically zeroes out all the values. Yep, it seems to do just fine. Okay, so everything's been zeroed out. It does a lot of things for you to be able to make it easier for all these kind of things, so you don't have to worry about so much of these things. Anyways, point is, if you activated the IK here, it wouldn't pop, and the up vector is very easy to set up. You could even use, like, if you wanted to use this as an up vector, and you just click here, and you go align 3-point middle, using its own axis, you could then point, because as long as you are moving it along this axis, that will not make the elbow move. The second that I move it along this axis, it would make the elbow move. And I can do that very quickly. I'm going to go skeleton, create IK, and there we go. So you'll notice it did not pop. And if I do, I think it's this one and then this one. And then I go constrain. I want the pull vector. There we go. So there, and you'll notice it didn't pop at all. So if, just like I predicted, if you move it along this axis until you pass the line of this line here, the brown line that you can barely see, which is the gold line. As long as you don't pass that line and you move it along that axis, it's not going to move the elbow. But if I move it on the Z axis, it will move the elbow. So that is an important thing to know. Then the last thing I want to show you in this tool is if I select this object, let's say I'm just going to rotate this like so, and let's say this one too. Let's say I have something that got messed up. I'm going to turn off the ability to select meshes, so make this easier. If I select that and then select that, this is called a slalom selection. You're going like left and right like a skier. You're selecting one, then the other, then the next one, then the one that it'll affect. And you go to a line and you go mirror translate slalom. It will figure out the value necessary to create a precise mirror on both sides. And this is something that, for whatever reason, they created a tool for you to be able to do mirroring of a skeleton, but that always creates something. So if you need to mirror something in Maya in particular, it's very difficult because you have to basically create a duplicate skeleton with it and then use the match tool one by one and realign each one so that they match. And that's very tiresome and very time consuming and quite frankly a waste of time. So hopefully you'll see the value in tools like this to be able to speed up your pipeline and clean up little tiny values that aren't right. And the align tool is the align tool is super useful. So yeah, I'll show now the rest of them, but that one's clearly one of the ones that you wanna use. And feel free to copy what's in them and take them to wherever you go and work, because these are kind of things. These are the holes I'm hoping they're gonna fix and plug in the future inside of Maya. Although I've been waiting a very long time for these, so here they are. All right, so next up is the shape button and the things that are in that. Okay, so maybe what we can do is, well, we talked about bacon shapes and the benefits of having joints as the transform. Whenever you want to see what the transform root is, or if it's a transform node or if it's a joint, you can always go into the outliner and go display the shapes. And now I tried to avoid this sometimes because it gives you the impression that there's more in the hierarchy than meets the eye. But like that one object that we have now looks like it's two objects and that there's a child node attached to it, but that's the shape. It's not actually something with a transform, weirdly enough. Anyways, point is, the shape is now showing up, and it's showing you that this is attached to something called a bacon joint, and then the bacon joint shape. But when you select this object normally, just normal selection, you're going to see the joint is there, and the shape is here as well. Like all the bacon options that we talked about for, if you didn't see it, please rewind and take a look at the bacon joint. I go into detail as to the advantages of using something like a bacon joint shape. So the other way is also just like I was doing in the previous part, is just going to the attributes, and you're going to see the second that you see the word joint and joint orient, you know that this is a joint. So I'm just going to turn this off here so we don't get confused. See, this is just one object, or one object with a shape attached to it, and it's always going to show you the shape on top of it. So if I bring in a Maya default locator, it's going to bring it down here. I'm going to bring that on over. If we look at this, it's going to show us locator and then locator shape. And there's no options for it. And if we go into the attribute, go into the shape, we'll find some options for it, but it's not a heck of a lot of stuff to work with. Now the other thing is, if I turn this on again, just to see, you're going to see that now this little symbol showed up, the little white parallelogram thing with a red arrow going through it. That is what that's the icon for a transform node. So at the base of locator, it's a transform node. So basically, what I talked about before was you can transfer the visuals, or what Maya refers to as a shape. Any visual can be transferred. That includes NURBS, that includes polygons, that includes anything. Anything that's that's not the position, rotation, and scale, that can be transferred to any other object. And you're using just Maya commands, really, that are built into Maya. It's just they never made an interface to be able to do this kind of stuff. So if I want to, I can just grab, let's say I grab these two bones here, and I go, show me these as, or add a shape that is a bacon-shaped bone. Book. Now, automatically, that button will automatically make it into things that are easy to select and visualize. So these joints now you know that there's the arm, you know its exact length because of the distance that the child was, and you can modify any of these features. So you can have the X-ray. In the case of the locator, you can never get a locator to be an X-ray, even if it's a joint as the root node of the or the transform aspect of it, and you have joint X-ray on that little button right here that I'm pointing at. So if you were to create a default locator or locator with the joint actually as a root, and I bring it in, you'll see that though I have joint to be seen as X-ray, it doesn't include the shape that's attached to it, right? So that's a bit of a problem. It really is just the joint itself that will have that feature, unless you're using one of these bacon shapes, which I have the feature built into it so that you can turn on the X-ray. So there's a lot of advantages to turning your joints into this. It avoids having to create circles, spline circles, and then attaching it to the joint, and then making it so that's on the outside of the mesh, and then you're always playing with that in your rigs. Here you can make any shape you want, have it in X-ray and all the other features that it comes with. Very handy. If you want to remove it, you just go into shape and you go remove bacon shaped bone, book, and it's gone. You can do other stuff like, for example, that's not the only shape that bacon shape, like all the bacon strip tools have. For one of the ones that's very handy is, let's say I want to create a line between these two, and I want the line to, when I select the line, it selects the pull vector. So if I select the pull vector here and the elbow, and I go shape, add bacon shaped line, it'll create a line between the two. So no matter where I move this, it keeps drawing that line, and you can change the color of the line and so on. And when I try to select the line, it will select the object that I first selected, and that shape will be attached to this object here. And now if you look at that, we have shapes on, so showing me that the bacon shape has, or the bacon joint has a bacon joint shape and a bacon joint line shape. And if you want to remove it, you can just click delete here, and that would get rid of it too. But for the sake of, I don't know, for utility, you can just come in here and say remove any bacon shaped lines, and that's it. So that's nice and easy. You can add shapes to anything really. This isn't limited to joints. Another thing that's useful, and this goes for anything, not just the bacon strip stuff. I've added that function that's inside of Maya that you'll see in a lot of videos that explain how to do that. Like if you want to transfer a shape onto another object, it uses the parent command. Believe it or not, it's just the one that we use in order to do hierarchies. Well, technically it's in the hierarchy, and you use the shape flag. You turn that on and you say transfer the shape to and make it now child of this other object. So I put it here. I don't use it too much because you actually have to go in and select the shape itself and make sure you're not selecting the root of that object or whatever it is that's transforming it, the transform aspect of it. And if you wanted to, you could take this shape and then transfer it to, let's say, this over here. So if I do select this and then shift select that, the default command that you'll find in a lot of these tutorials, it will do it, and it will transfer. Now that shape is over here, so when I select it, it is now part of the upper arm, and I have all the options like I usually do. You have, there's only one shape here that's been added, and that's good. You could do that. Another thing that can be useful is the way I have it here. It's much easier. So like, let's say I have create polygon. I'm going to create a cube. And I'm going to make the cube something like that. All right, now I'm just going to eyeball this. Just imagine, this is a horrible way of doing it, but anyways, you get the idea. I'm just basically saying I want this to be my arm. So when I click on it, I want it to select my arm. Oh, I turned off the mesh selection. So now I can select this. So I'm going to just select this and then select the joint. And then I'm going to use that button. And now you'll see that we have a transform node that's naked. We lost the shape, right? That was the cube we moved into place, but it lost its polygons or its shape, and it got sent to the upper arm. And you're going to see that over here is now, you see the P cube shape has been attached to the upper arm. So if I minimize that, you're going to see it clearer, right? So and this works for everything. NURBS. Oh yeah, and another special feature this has is it auto detects if it's a polygon. Because normally, if you use the default command, it's not going to take the current position where it is into consideration, and it'll just move it relative to where it was relative to the original transform. So you'll notice that when I transferred it, it stayed exactly to where I had it. So it'll do it relative to where it is in the world, and it will recalculate the vertex positions to match the joint that it's going to, or the object that it's going to. And that's a neat little feature that it has built in. I auto detect if it's a polygon and do that. Same thing goes for circles. So if I create NURBS primitive circle, and I'm just going to bring this, I'm just going to do this as quickly as I can. We're not going to really worry too much about it. If you use the traditional tool for transferring this, everything I'm doing right now would be lost. You would lose, and you'll notice that, well, you know what, I can do it real quick here. I select the NURB shape, I select this, and I use the one that everyone uses as a reference because it's a simple little script. So if I click this like so, you'll notice that everything I just did to place the circle is gone. By default, the circle is placed, and it'll never be relative to the x-axis. It's always going to be just like as if it was on the ground, which means we're doing a y up. Anyways, point is, I'm going to undo that, and we're going to use the feature. We're going to use the auto detect feature that this tool has. It's going to detect that it's a NURB spline, and it's going to adjust all of the vertices so that they stay exactly to where they were when they were attached. And that's doing all of the heavy lifting and behind the scene. From our perspective, it's simple. We just want to place our shapes wherever they are and be able to attach the visual component of any object. You call them shapes if you want to, and attach it to whatever your object is. I think that goes through a lot of things that are very useful to us. Like we can't disregard the there's a whole science to find. Frankly, there's a lot of work that's always involved in getting your rig to be easy to understand. And if you don't have these basic tools to be able to transfer shapes from one thing to another and adjust them so that you're not tearing out your hair, it makes everything harder if you don't have this. And with this, you'll be able to actually make rigs that are easier to understand. And when a person starts to animate your rig, this alone will help a lot. And these like the feature to transfer splines and polygons and stuff like that works out of the box in Maya. So you don't have to worry about any of my plugins or anything like that. But the ones that have the BS plug next to it means it's probably using one of my plugins. So that's why I marked it. Okay, so you're going to find that we have also a duplicate button. This duplicate button, at first you're probably thinking, why? Control D is good for me, and I have Shift as well. So let's say I want to take this upper arm again, and I go into translation, and I Shift drag it. Now the problem with this is that you're going to notice it came with all of its child nodes, and quite often a lot of people, while they're rigging, might use the Control D function, and for whatever reason they think they're in an Excel or a Word or something, like every other software, and all of the things in the hierarchy will come with it. And they forget about it and they just leave it there, and then they find that their hierarchy has like duplication everywhere, and not just the thing that they wanted. So that's kind of a problem. And a lot of people will be like, "Oh, it's not a problem. I just duplicate it like this, and then select the child node. Now I have this duplicate. It's okay." Sometimes that can get really messy, and it's difficult to find what you're looking for. So sometimes the best thing to do is just to select an object and use this button here to duplicate with no children. Now it'll duplicate the object and not have all the child nodes. Other things that are important is that whenever you're duplicating something and you're using Control D or Shift, anything that's hooked up to it, any constraints and all that stuff, it won't keep those. It won't connect. It won't create the connections. It'll just duplicate the object, and basically anything that was like, let's say I do this kind of thing. I grab this and I go, okay, I want your orientation to match this. So I'm just going to do constraint, orient, constraint. I'm just going to do it like this. And now if I grab this, it's activating that sort of thing. And now if I want to duplicate this, I do the usual thing with Shift or Control D. I do that. You'll notice that it didn't come with the duplication of the constraint on it either. So this clearly had a constraint. This does not. So pretty simple. You go into duplicate and you say, I want connections with or without the children, depending which one you want. And now you're going to see that this constraint is active on both of these. And that goes for anything that would be connected to the bone. It will find any connections coming in and say, okay, I'm going to maintain those connections. And this is good when you want to replace stuff too. Like if you're going to be replacing something and don't want to rehook everything up, this is very valuable. Other than that, there's also duplication of objects like curves. What we talked about before about shapes. So let's say I create, let's see, a circle. And like we did last time, I think I was working on this this arm here. If I rotate that, and let's say I'm happy with this shape, and maybe I make some vertice changes, I don't know, for whatever reason. And I want to make a now duplicate of it on the other side because I want to have a rig that is properly mirrored. There's no tools in Maya to really mirror these things. That you can mirror a lot of stuff, not splines for some reason. So if I right click on this and I go the curve, it will create another one on the other side. It won't move the transform and mirror it. It'll just leave it wherever the other one was, but it'll move all the vertices so that they're exactly on the other side. And then we can use the other tool that we had before. If I go like this and go shape, transfer shapes. In fact, I'm going to use the slalom technique so we can do both at the same time, like so. And I'm going to do shape, transfer, slalom. And now what I've done is this side is identical to this side, and we're happy because our rig is, even the controls are now mirrored, right? The other duplication tool that I have in here is for hierarchies. So let's say I don't have, well, I'm just going to move this arm out of the way visually, okay? And I want to duplicate this. Now, if you use the skeleton mirror joints tool, you can, like I have it set up so that it's going to mirror the behavior, like the default. This is good to go for the most part. And it's going to try to do the naming, based on the naming convention, it's going to try to take any underscore L and replace it with underscore R. So for example, when I'm working on like toes and I have a toe left, well, there's an underscore L in there because of lift. And then if it tries to rename it, it calls it rift right. So this tool is not great, but at least it allows me to create a proper hierarchy with the rotation in the way that I'm looking for, that it mirrors the behavior when I'm rotating it, right? So at least that's functional. It's just that some of the naming might not be perfect. So what this tool does, it basically does the same thing, and you can do multiple selections because when you're adding, like, let's say what I call the fins, like these extra nodes, to be able to control, like to make an envelope that's better for the skin later, and to help it find what volume is attached. Anyways, let's say you have multiple objects, not just the one node that you want to duplicate onto the other side. Let's say you want to do the leg too. So I'm just going to move this leg out of the way so we can see it in action. So I grab this thing, I grab that thing, and I go duplicate mirror hierarchy. It's going to name everything correctly. And you can do multi-selection like it just did. And now you have everything like we said before. It will mirror in behavior, and it's going to also freeze the rotation on the joints if it detects it's a joint. And it'll create a mirror with better naming convention where I'm using Python parsing in order to be able to just grab the thing at the end of your names and not the whole name. So it's much safer to rename. And that's it for the duplication tools. Okay, so now for the constraint button. What we're going to be doing is there's a lot of stuff to go through here, but I'm going to break it up into two sections. First section is for bipedal characters and for a bipedal setup. So simply put, let's say I want to add IK to this arm, for example. You have two choices. You could just select the hand. Like many other tools, I always have it so it's always the leaf node, and it will go up the hierarchy because you can always have multiple children, but you can only have one parent. So this guarantees that it's going to find the elbow and the shoulder. If you did it in any other order, that would be bad. So all you have to do is select the hand, and then you go into constraints, and you can decide which kind of IK you want to use. If you want to use the default Maya IK, you right-click and hit that button. And now it will have set up the rig so that you have a very traditional kind of setup with a pull vector and everything built. Well, that's normal. Yeah, you don't cross the goal line. That I think that's pretty clear. But for the most part, everything's here. You have your entire setup, and it's using my default IK. On the other side, I'm going to use the different one. Which is using the bacon strip IK, and there's some advantages to using the bacon strip IK. So in both cases, the scripts auto detect which side you're doing it on, and will change colors depending if it's left or right. If you're using the Unreal Engine kind of naming, where you put a underscore L or R at the end of the name of the bones, it will detect based on naming and also on the mirroring. Both of these are compatible, so if you look at these two, you'll see that the mirroring is in effect. And the advantage of the bacon strip one is that you can also squash and stretch. You have a lot of features for stretching and such, so that could be really handy for a character that is more cartoony, and even for a non-cartoony one. You'll notice that when you get close to that, just having that little tiny stretch, even if it's just a little tiny bit, that can be good for a realistic rig because you're avoiding pops, or at least you're smoothing out pops. And at the same time, even though our arms don't really stretch, we do have these, like if you try to straighten out your arm, you can do a little bit of that effect. Okay, so now what I'm going to do is I'm also going to do the feet. And just a quick reminder, for the feet, you do not select the feet, you select the toe base. And I'll do two at the same time. This has been changed for my students. I made it so that only one leg would work, and I made it so that if you tried it on the other one, it wouldn't work because I had them transfer and do the rig on the other side. So yeah, they had a bit of a shortcut on one side, but I needed them to learn how to do it on the other, so not to have too much auto generated. And I might go back and change this, but for now, if you right click and go reverse foot and you've selected toe base or the toes, and you click it, it will create a reverse foot, also detecting which side is left and right. and applying the correct colors, and also making it so it mirrors. In this case, though, in order to maintain zero outs and to make sure that it's useful for everybody, I made it so that there's these little construction nodes. So let me just switch to world. Wait, hang on a second. Maya's having a little bit of a connection here. There we go, world. So if I move this around, because you're placing, you'll notice that nothing else moves. Everything is staying in place. Let's say I move this over here. And now we're going to use some of our fancy tools for mirroring. Like maybe the toe tip should be about here because that's where the weight would pass. So I'm going to just do this in slalom order. Select the one that's good, and then select the one that you want to affect by multi-selecting. And then I'm just going to use the previous tool that we talked about, mirror transfer, and it should pop everything into place on the other side. And now that we're done making our tiny little adjustments, we can go into constraints again and do remove construction nodes. By doing that, you now set it. You've basically completed your rig. I'm going to hide the joints here in this case, just so we can see clearly what we're doing. You'll notice that we have our rig all set up. All the joints are also zeroed out. Like if I look here, everything's zeroed out. And it's nice and clean, and it's also working in mirror. So we can pretty much have a foot planting nice and easy with this. And it's just a very traditional reverse foot. That's all it is. That's all it is. Okay, so now for the other constraints, I'm going to go over some of the some other methods and other types of constraints that you might want to use that are beneficial because you're using bacon strip. So we're going to use our imagination here a little bit. This is an arm. This is a shoulder. This is the upper arm, the lower arm, and these are the bones that we're going to be skinning on. Okay, and we want to do a bendy bone setup where we have multiple bones that are what's being skinned to the arm, but then we control everything through the usual upper arm controls and so on. And all I'm going to do is I'm going to unhide these shapes that have shown up. And just like a Bezier, we have a starting point, an ending point, and then 2 points for the tangents. And this is the bone that we're going to be using for skinning. So I'm just going to make a few copies of this. I'm going to make a few clones. It's good enough. Okay, so we could do the same thing in the other one, but I'm just going to focus on this part here, the upper body, the upper arm. And the order in which you select things is very simple. The starting point, and you just go down the hierarchy, or the order in the direction of which the arm goes. And then you multi-select all the ones that you want to have as whatever number of bones you created for the skinning. And then you go into constraint, and then you go bendy bone. And now it'll snap everything into place, and you should have the ability to select the tangents and change the curvature. And if you look carefully, you'll notice that if this is the animation that you were doing, all of the skin work that you did here on these little tiny bones will follow along. So you can have your traditional rig, and then on top of that, you can then do stuff like this where you go, okay, so now I'm going to lower this like so. And now I've got a nice little bend going here. And you can do this kind of stuff, depending on what your character's doing, you can pull and so on. So you can do that on both of them, and then you'd have the ability to make your character be much more flexible. And even if you're doing a realistic character, sometimes being able to do little tiny adjustments to make it look like the things are making contact, this is an easy way of doing that, actually. And because it's a Bezier, we're very much used to the concept of tangencies, especially if you're doing you're looking at your graph node. So it's like your F curves are being adjusted this way anyway. So we're used to this kind of concept for your keys, for adjusting keys. So that's a nice little constraint to have. Let's take a look at some more constraints. I'm going to look at twist bones. Twist bones. I have videos talking about this in detail. Here, I'm just going to show you the basically you could set them up very to be as mathematically accurate as possible, because it's a long story. But using old traditional methods, there's always some sort of an issue, and because it's using Euler calculations, there's always issues with that kind of stuff. So here I've built it so that it completely ignores Euler, and the entire thing is built on quaternion mathematics. So in order to show you what this is, all we have here is a hand that's going to be our point of reference. And that hand will affect these bones so that they only inherit the roll. And all you have to do is select the hand as the reference, and then select in the order in which the joints go upwards for the skinning for what's going to be twisting, what's going to be rolling. And you go constraint, and you go bendy bones. No, not bendy bones. This is a bacon roll. So bacon roll bones. So you just do this. And now if I look at the animation that I have here preset, you'll notice that's very stable. There's nothing jumping. And then when I roll the hand, it's doing an average. It's cleanly doing that. So if I just grab the rotation, if I just grab this hand, you'll notice that the gizmo might be changing color, but there's nothing spinning, rolling out of place. And that goes for this axis too. This is a very stable method for doing rolls. So I strongly recommend using this. All you need to do is make sure all of your things have been zeroed out or frozen, and just keep that in mind, and everything should work out nicely for you. So yeah, that's one way of doing like the roll bones. And lastly, we're going to take a look at feathered wings, because this is going to be a double bacon Bezier, because we're going to use two Beziers to control wings, and I'm going to give you an example here with this. All I've done is I've created a basic structure for the wing, and I've created these nodes which are going to be what controls the Bezier. So for example, this joint here is the starting point well, I'm just going to focus on this part of the wing. We could do that one easily by just doing exactly what I'm going to do here. But I'm just going to do this side. If I select the first Bezier, just like before, I select the first Bezier starting point, and we're going to go in this direction. We're going to use these as our tangent controls. So I go like this. Okay, so these are the 4 points for Bezier, and that's where this curvature will control where the starting of the feather is going to be, and then the bottom half is going to be another Bezier. So that's its starting point. This is a tangent, another tangent, and then the ending point. And that's all we need to know about the two Beziers. It might seem like we're selecting a lot of stuff, but once you see how it reacts, you'll be pleasantly surprised. And all I'm going to do is just select, and you can change the order of how many of these you want and whatever. It's just going to grab whatever you select in the order that you selected and place them as wings to match these two Beziers. So if I go into constraint and I go bacon double Bezier, it'll snap everything into place and start drawing and displaying what the Beziers are based on those objects I selected. You can control the wing quite nicely doing this. And like if you do this kind of stuff, you'll see that it is very stable, and again, mathematically very clean. So you're going to get these nice curvatures, and you can control how much of a curvature there is, and everything is, including the twists. You'll see that if I use the local here, I don't know what's going on today with this thing, but anyways, I want object rotation. There we go. So you'll see that everything is very coherent. Everything is working nicely, and you're getting these nice curvatures that you can use to create shapes that you normally wouldn't be able to using a traditional, let's say, averaging method. Everything's very linear and very flat. With this method, you'll be able to do quite a few things and control exactly how you want the distribution between these two curves to affect the feathers. And that's probably one of the best setups I've seen for feathers. Although it's not perfect, but I find it's very effective, and it works pretty well. So I would use that. And I think that pretty much concludes all of the ones that are here. There's going to be more that I'm going to add over time. I know that I'll be adding like the quadrupedal IK. It's a special IK just for quadrupeds. And just like we did with the reverse foot, you're still going to be selecting the foot toe base. and then just clicking on the button and it'll generate it. For the most part, I'm just going to be adding more and more stuff into that, and that'll be great for Rigonomicon, which is for learning. And for Bacon Strip, all of these buttons are probably going to go into a menu and make it easier, and I'll probably do the things that you should be doing for scripting to be nice and clean. In this case, if you want to know how I'm doing any of these, I mentioned it a few times now. If you open up the window and edit it, you'll find that everything is self-contained, and there's a couple of them that are pretty big, like the reverse foot here is going to be a big one. But considering everything that it's doing and auto-detecting and so on and setting up, and that this has been rewritten for CMDS commands instead of PyMal, there's a lot you can learn from just looking at these scripts, and these are all self-contained scripts. I made it exactly like this because for learning purposes. Okay, let's move on to the next button. All right, so up next we have the physics button. I've gone ahead and created a little scene here that'll make it easier to explain this. Now, one thing I want to note is that this is I'm using plugins from a third party. In this case, it's Akasakisan, who created these plugins that allow us to do some real-time physics. It's more like real-time spring physics, more than physics. There's a lot of tools in Maya, like Bullet and such, that give you physics, but I find they're not very friendly for rigs. Especially in the current state while they're doing the evaluation manager changes. It's not so great. Anyways, point is, this button will allow us to create some physical dynamics very quickly. So let's say, for the most part, the tools, unfortunately, that come from Akasaki-san don't have much of a way to create the scene, and there's a lot of manual, a lot of stuff that gets done manually. So what I've done is I've created some scripts that generally take default joints in Maya and use the radius setting on a joint. So if you look at any joint, you should see something called a radius, and that will allow you to change the volume that these objects have. So in the case of this chain, where the physics is going to be, so let's get that started. So here we have the 3 joints that they're gonna have physics. I'm going to add dynamics to those joints, and now if I'm in anything other than frame 0. Should be able to just move it around, and it will follow with some dynamics. And you'll always notice that over time it'll return back to its original state. That's why I call it a spring collider. Now, in order to make things simple, like I said, the volumes that you can add that can be colliders for this physics, it's just using the radius. And I've just added a visual component to it here, but you don't need to do that. You can use your joints to radius straight away. It's what it's going to use to determine what the radius of the sphere collider would be. In the case of a radius, in the case of a capsule, you have two spheres basically with an interpolation between the two, and we're going to use basically 2 joints, and that will define our capsule. It doesn't need to be more complicated than that, and this is actually very useful to us because in a skeleton, this would be, let's say, your femur or your upper arm or whatever. You have these joints already, so all you need to do is define their volumes, and that's it, by changing the radius. So okay, so now I'm going to add this sphere to those 3, and I'm going to add sphere like that. So now if I move this around, boop, it'll collide with the sphere. All right, and if you look around, you'll see that this is quite stable, works rather well. Kudos to Akasaki-san for giving us something clean and simple that works in Maya, because right now the tools for Maya for this kind of stuff has not been great. I'm waiting for updates, so it'll improve. In the meantime, you have this. This is great. So if I want to add this capsule, you select the child node. So if this was like an upper arm, you'd select the elbow. And then you just do the same thing, only this time it's capsule. And then it will understand the volume that it'll collide with based on the dimensions of that capsule. So if you're in the middle of it, it knows how wide it is and such. So as you can see, it works just fine. It's a nice and easy way to add a little secondary motion to your rig in a very little amount of time. Okay, so the next three buttons are going to be done together because they're all part of the same idea. The only reason they're broken up into three parts is because this is for ease of use, to be able to quickly define things. I'll explain that in just a moment. In the future, I'll probably combine it into one button so that it opens up its own interface, which will have these features built into that interface, and will add some functionality that we don't have right now. But for the most part, the concept of a preheat is very valuable to us, especially if you're coming in with Maya out of the box. So what is this preheat? Why is it valuable? Because in Maya, there's a bit of let's say a gap in how you can transfer animation from a character that is not necessarily the same proportions, or simply just motion capture. You want to transfer motion capture onto your rig, onto your custom built rig. Then if you use the built-in human IK tools from Maya, you will destroy your rig because it will override the IK and everything with just keys. It'll just dump all the keys onto the skeleton and destroy your rig completely. So this is not something you necessarily want to have. So these tools are to bridge that gap so that you can transfer non-destructively animation from human IK onto your custom rig without breaking it. And how it works is actually pretty simple once you understand the concept of a surrogate skeleton. So over here, I went ahead and I brought in a very basic custom rig. So you have your IK set up, you have your upper body controls, and you have reverse foot and all that stuff, okay? So there's nothing special about it, but we still want to preserve this because we don't want to lose our rig after we've transferred the animation. Kind of defeats the purpose of having a rig. So if we go into, I've added this skeleton here. This skeleton is just a copy of the skeleton that was used for the rig, and it is placed in exactly the same position as the initially with the custom rig. Now what we're going to do is, and I've already done it here, but all you need to do is understand, like, this is a surrogate skeleton, meaning it is something that if we add keys to it, we don't care. It doesn't matter. It's not breaking anything because it's an independent skeleton not related to our rig. So if we transfer keys to it, like motion capture, it would be perfectly okay and nothing would break. And all we need to know is how to transfer that data onto our rig without breaking things. So what we're going to do is we're going to cherry pick and define which bones are going to transfer data to our custom rig. So in the case of a pelvis, it's an easier one to understand. A pelvis is a very central point, and it's got position and rotation that we want to transfer. So when a white skeleton receives its mocap data, we want to be able to say very specifically, we want its position and rotation to transfer onto the thing that controls the center of mass. So, and then at that point, it would add keys to this. Okay, so think of preheat as a way of doing a deferred bake. I call it a preheat because you're not setting it up to bake yet, but you're setting up instructions for when the time comes to bake, it knows what to do. And one of those things that we're going to do here is we're simply going to take this object that will have position and rotation values that we want, and we want to transfer it onto this center of mass control, and we would press the TR button. And that would send the signal to say, when it comes time to bake, I'm transferring position and rotations onto the center of mass. Now, you don't always need to do translation and rotation. You could also just do rotation, like in the case of a spine joint. I would do something like this. I would select this one and that one, and then I press the one with the R by itself in blue. That means it's just rotation that we're going to be transferring onto our controller or whatever it is that we have in our custom rig. Okay, and then we do that for all the joints. Once we've done that, and we have this kind of like understanding of when data was going to when mocap is going to come in, and it's going to be on this skeleton, we have this understanding now of where it's going to go. We save that, and we never have to do it again. After that point, you have this surrogate skeleton that can do this for us at any time that we need. So I'm just going to hide this for a moment. Just know that not only did we assign this to our rig this way using these preheat tools, but we also did the characterization or the defining of the character in here, so we know that a human IK knows how to transfer data to it. Okay, so that's all we've really done. So if I select this and hide it, we're back to just having a rig. If I go ahead and import mocap, let's see here, mocap source 3 should be fine. So this is some mocap that on a skeleton that's been characterized as well. And all I'm going to do is I'm going to use the human IK tools to, and this is not the same proportion, or it's a similar height, but not the same proportion. This is coming from another source. I'm going to take the data that just came in and transfer it over to the other one. So I'm going to hide this source, and I'm going to unhide the one that we were looking at before. You see now that it's moved, and it's we've transferred the data. Well, it hasn't been baked yet, but it's transferred. It's a live transfer at the moment using human IK tools. Now that everything's been set up for all this, it's easy to just transfer it. All we need to do is press the bake button and just give it a moment. Like you'll have a little progress bar down there, and the baking complete. With there seems to be no errors. It's passed, and now if we look, we have our data that has been transferred onto our rig. Now I'm going to hide the surrogate skeleton, and I'm going to see if the rig is broken. And sure enough, it is not broken. It was preserved. I can still animate on top of this. The skinning for this is pretty broken, but anyways, the important thing here is that we transferred the animation safely onto a rig without any problems. And the rig continues to work. We still have our reverse foot and everything else. So we can do what we need, and we can work with this. We can continue to work with it. So this tool is this little feature that I've added here. These buttons are very handy for anybody transferring motion capture, or even just trying to transfer animation from a character with a different proportion. Okay, and the final button in the shelf is going to be one for making adjustments to our skeleton without affecting the skin. And for ease of use, I've also added to the button the ability to quickly get to the paint, so we can affect our weights and everything quickly through that button. It's just for ease of use, but the more important part is the ability to move and rotate joints without affecting the skin or the vertices that are skinned to specific joints. Now, some of you are probably going to say, well, there's a mode in here. If you go to skin, move skin joints, that should say move skin joints tool, because it will activate a specific tool. And if I select something, and while I'm still in that tool, it will allow me to move it. And you can always tell that it's working because everything gets wireframed out. So that's actually a feature I don't really like too much. And let's say that I want to move it here, and all you'd have to do is switch to another tool, and it will end this mode, or this tool mode. The thing is, though, let's say I want to rotate this thing. The interface here does not have something for me to be able to rotate the joint. So if I press rotate, because rotate is technically its own tool, right? Position, rotation, scaling, gizmos are all tools. The moving the skin joint is only moving it. It really isn't rotating it either. You couldn't scale it either. So, which is a no-no anyways in rigging, but let's say you wanted to do that, you wouldn't be able to here. And so what's important here is that I can show that the tool did work for moving it, but it doesn't work for anything else. And that's a big issue. So some people work around this problem. Instead of getting a tool that does it properly, they end up outputting the skin weights into a file. They then delete the skin. They make their adjustments for rotation, and then reapply new skin, and then copy the skin weights back. That is a very long process to make tiny little tweaks. So I'm going to show you a method with the Rigonomicon shelf, which should bypass all that and allow you to, and here's the best part, I'm not actually rewriting anything. I'm like some of the other tools, I'm just making some features that are in Maya that are not accessible in Maya for some reason. They never created a UI, and I'm just adding commands that allow me to access these features. and these commands. So in the case of the skin moving tool, the tool itself isn't what's been written. They think of it as its multiple pieces. The only part we like is the part where, like, even the wireframe thing, we don't need that. All we want to do is be able to deactivate a skin and allow us to use other tools like position, rotation, and scale, like the traditional ones in Maya, to be able to make adjustments. And then we want to be able to reactivate the skin. And we're going to use the Maya tools to do that. So let's say I select this mesh, I select that mesh, I right click in here, and I go deactivate skin. Now I've deactivated the skin, which means if I move this around, it doesn't affect the vertices that are skinned to those joints. If I double click here, I'll be able to even use the preserve children, and now we've essentially recreated what the other tool was doing, but I'm using the default Maya translation tool, and that also means I can do rotations without causing any trouble. So let's say I have this set up and I want to fix the x-axis so that it points to the elbow here. I won't go into details why you want that. Hopefully you've been following along and looking at the basics of rigging to know why we would want that. So I'm going to use this tool over here, which is to realign the parent, which is the upper arm there that we were using, to get its x-axis to point to the child. And now if I look at this joint, it has an x-axis that's difficult to see, but well, let's see. Let me just go into object translation. Now you can see clearly the x-axis is pointing to the child. We fixed it, and it's also a little bit higher, which is something we wanted. So now once we're done with that, we might want to do a mirror over here. So we can do an align, mirror transfer slalom. Boom, that's fixed. And it's using the, once we're done, it will have the mirroring behavior. You'll notice the x-axis is pointing in the opposite direction. That is by design. So now if I select these two meshes and I go to skin and I activate it again, we've reactivated the skin. And if I select both of these, just so we can see the, we got to remove the preserve children option. We now have a mirror of the two sides with the adjustment that we just made. And this little tweak didn't take us very long to do. And we had full control at all times. That's what's important. And this is not rewriting anything in Maya. We're just using a feature that's already in Maya. And we're just presenting it in an interface that is useful to us. That's it. Okay, so that's the final one. I hope you've enjoyed watching these videos and found these useful. I hope there will be more tools along the way. And I will also be adding a bacon strip specific tool menu with more things in the future. But for learning purposes, I think this shelf in particular is an excellent shelf to learn how to rig and how to work around issues inside of Maya. Like I said before, Maya has holes in it, just like we just saw, and this should help you solve those problems for things that you're going to use on a daily basis. All right.